Dear students, now we discuss the transference or transport number and the relation between transference or transport number with the speed of ions or absolute velocity of ions or migration velocity of ions. We know that according to the first law we seen the Collar's law. According to the Collar's law, the total equivalent conductance is nothing but the equivalent conductance of cations plus equivalent conductance of anions. That anions and the cations migrate independently, is not depend to each other. Each ions contributes independently to the equivalent conductance. That is nothing but the Collar's law. Okay, suppose we have one example is there, MgSO4. Okay, Mg has the two plus sign and SO4 has the 2 minus sign. Okay, therefore equivalent conductance, okay, lambda 0. Okay, lambda 0 means the equivalent conductance at infinite dilution. That equivalent conductance is given by the equivalent conductance L naught Mg plus equivalent conductance of SO4 minus ion at very dilute condition. Okay, therefore it is having some specific equivalent conductance value, and this is having some specific equivalent conductance, and these equivalent conductance are not depend to each other. It is having something value at particular at very high dilution. Therefore the equivalent conductance of MgSO4 is given by the summation of Mg equivalent conductance of Mg plus ions plus equivalent conductance of SO4 minus ions. Therefore it has the value equivalent conductance is independent on other its ion, it migrates its towards respective electrode independently and not depend to each other, and the total equivalent conductor for this salt can be calculated by the summation of the equivalent conductance of first ions plus equivalent conductance of other ions. This law is nothing but the Collar's law. According to this law, each ion contributes to its total equivalent conductance independently to other ions. Okay, it is having something equivalent conductance value, it is having something equivalent conductance. By summation of this, you will obtain the total equivalent conductance of MgSO4. Okay, therefore equivalent conductance independently depends upon its ions. Like that, the current is also depends upon cation and anion. Okay. The current given by the cation and the current given by the anion is not sometimes it is equal, but sometimes it is not equal. Not necessarily it becomes equal. Current given by the cations or current given by the anion. Okay, therefore it depends upon the speed of ions. The current given by each cation and each anion is depends upon its speed. That is its migration velocity. We call it migration velocity or absolute velocity or speed. It is having something different speed, it is having something different speed. Therefore the current given by each ion may be sometimes same, it depends upon the speed. If the speed of both ions is the same, then it will give the same current, but the speed of ions is the different, then it will give the different that is current. Okay, therefore the current is carried by the each ion is the different, and it's independently work. The current due to cation is different, and the current is anion is different. They independently work, and it give the summation of it give the total current. Current due to the cation plus current due to the anion. If suppose current of the cation is the I plus and current of the anion is given by the I minus, then the total current, okay, I is the total current, is given by the summation of I plus and the I minus. Okay, one thing is clear, as like the Polar's law, the total current is given by the total current carried by the cations plus total current carried by the anions. The current carried by the cations and the current carried by the anions is depends upon its speed or the velocities. If the speed of cation is higher, the current given by the cation is higher. If the speed of anion is the higher, then the current given by the anion will be higher. Okay, therefore the total current is nothing but the current is obtained due to the cation plus current obtained due to the anion, that is will give the total current. Okay, therefore the another important thing is the what is meaning of transference or transport number. Transport number is nothing but the fraction of current to total current, fraction of current to total current by ions is called as the transference or transport number. If suppose I plus is the fraction of current, I plus is the fraction of current, then transport number is given as is fraction. Okay, I plus upon I is nothing but your transport number. Okay, therefore transference or transport number is defined as the fraction of current to the total current, fraction of current to the total current. Okay, that is fraction of current, that is fraction of current to the total current is nothing but your transport number or transference. Okay, now the two things we clear, that the current carried by the cations or the current carried by the anion give the total current. By the summation of this you will obtain the total current, and it depends upon its velocity or the speed. If suppose you take the MgSO4, okay, the transport number for SO4 is 0.62 and transport number for Mg minus plus is 0.32, that is transport number. Therefore transport number of SO4 minus ion is the higher, therefore its speed is the higher. Remember that. Therefore the transport number or the current is depends upon its velocities. Now the relation between the transference or with absolute velocity or the speed or migration velocity we can obtain here. Okay, therefore firstly we will find out the total current carried by the cation is the I plus, total current is carried by the anion is the I minus, then total current is given by the I plus I minus, then we will find I plus upon I minus upon I. Okay, these values, by comparing this value, by obtaining this value, we will obtain the relation between the transference or the transport number with the migration velocity or the absolute velocity. If suppose we have such a cell is there, Okay, like that, there is a cell. Okay, there is A, B, and A dash B, then C dash D dash C D, E dash E F, E dash, and F dash. Okay, and this is one of the electrode is placed at that side. Okay, here is one of the electrode is placed, and other side other electrode is placed, and our electrolyte solution is placed in this cube. One at the one side there is one of the electrode, at the other side there is, okay, at this side there is a cathode is there. Okay, cathode is the negative. At the other side there is the anode. Anode is the positive side. Okay, you apply the voltage V. For this you apply the voltage V, and then when you apply the voltage, your electrolyte inside the ions migrate to the respective electrode. Therefore the positive ions, that is cation, migrate to the cathode, and anion migrate towards the negative charge migrate towards the positive side. Okay, anode, at the anode. Okay, therefore your cation, okay, suppose you have that is cation has the average migration velocity or absolute velocity is given by the V plus the charge on cation. Okay, charge on cation is given as Z plus. Okay, Z plus. Then the number of cation is given by the N plus, and then last one is the electricity associated with unit electrical charge is E. Okay, therefore if suppose if you have Mg plus plus ion is there, then your Z plus value is equal to plus 2, that is charge. The charge on Mg is the plus plus, and the electricity associated with plus 2 charge is E. For unit it is E charge, electricity is the E. Therefore electricity associated with unit electrical charge is E. Okay, if plus 3 is there, then plus 3 electricity is associated with this charge is the E. Okay, now if you see the current is given by the inside this box, or this electrolyte is placed inside this cell. Okay, that cell A, B dash, C dash, E, F dash. Okay, all this. Okay, this slice or this slice, in between this slice, here positive charge will migrate cathode, negative charge will migrate to the anode. Okay, we will firstly find out the current, total current given by the cation is the I plus. Okay, therefore the current depends upon or directly proportional. Okay, if speed is higher, then it gives the higher current, because it deposited fast to the electrode. Therefore the speed is higher, then it gives the high current. Okay, therefore your current is depends upon its velocity. Okay, V plus velocity, directly velocity increases, current is increases. Then it also depends upon the charge. If charge is increases, current is increases. It then depends upon the number of cations. Okay, therefore cations increases, your electric current is increases, because number of ions is the more number of ions is there, more now it gives the more current. More number of velocity is there, it gives the more current. More number of charge is there, it gives the more current. Okay, therefore that relation, current is depends upon the velocity. Velocity is fast. If velocity is fast, if you have the mg plus plus, if the velocity is fast, is fastly move towards the your cathode, that is negative charge electrode. Mg plus plus fastly move towards the your cathode. Okay, that is having the negative charge. It fastly moves. Therefore, fast move give the fast current, more current. Okay, therefore velocity is higher, it is having the higher current. Then Z plus, the charge is higher. Charge, okay, definitely charge. It gives electricity, charge, and E give the produce the electricity. Therefore, if charge is higher, it gives the higher electricity. If charge is lower, it gives the lower electricity. Okay, therefore charges is more, the electricity is more. The number of cations is increases, charges is increases. Remember, number of cation N plus is the increases, your charges is increases. Therefore, the your current is depends upon these all factor directly. But your distance is increased. Okay, that distance is the d distance. Okay, first electrode is separated, anode is separated from the cathode, the distance is the d. Okay, therefore the distance is increases, therefore mg plus plus require more time to deposit on this cathode electrode, and it's require the less current is produced, because as fastly as quickly as it deposit on cathode, it gives the more and more current. Okay, therefore the current is depends upon the its velocity, charge, number of ions, and that E is the electricity associated with unit electrical charge. Okay, therefore this is all about the cations. For the anions, the charge is anions is the Z minus, okay, and A minus, okay, anions. The number of cations is the N minus, and the velocity of anion is the V minus. Okay, the important things we have seen. Average migration velocity for the anion is the V minus. The charge on anion is the Z minus. The number of anions is the N minus. And electric charge associated with both. Okay, E is the constant one because it is charge is the having electricity has no current is not having them. That is both cases E is the same. Okay. Okay. Therefore, the current is due to the cation is given as, okay, we have seen that V plus Z plus N plus E upon D. Okay, the current due to cation, okay, current due to cation inside this box, okay, A B C D, something box is there, A B dash, then C dash, okay, like that, A B C D E F G H. Okay, in this case G H is there, E have G dash, H dash, and G and H. Okay, in this box A B C D E F G H box, the number of current cations given by the like that. Okay, the number of current is given by the anion is equal to V minus Z minus N minus E upon T. Okay, then total current, we know that total current is nothing but the summation of the current of that cation and the current of the anion. Therefore, total current I is the I plus plus I minus is equal to V plus Z plus N plus E upon D plus V minus Z minus N minus E upon D. Okay, like that relation we have found. We know that the our velocity may be different, but the charge and the number of cations is always equal. Okay, number of cations is equal to number of anions. Okay, for the simple sort. Therefore, it is also Z minus and the N minus. Okay, therefore instead of Z minus and N minus, we will put the Z plus and N plus. Okay, is equal to V plus Z plus N plus E plus, okay, we have V minus is the different word, and then Z plus and N plus E is the same, and D is the common. We take the distance between two electrons. Okay, therefore the common factors inside is the Z plus is common factor, N plus is the common factor, E is the common factor. Okay, inside the bracket you will find the v plus and the plus v minus upon d. Okay, that particular things we will find. Okay, now we'll solve this. The common factors I is equal to, you will obtain the z plus, then n plus and e in bracket v plus v minus upon d. Okay, like that relation we have obtained. Okay, therefore we know that the transverse number is given by I plus upon I, that is the t plus. Okay, small t plus is the transference or the transport number. It is nothing but the fraction of current to the total current carried by the ions. Whether it is cations is the I plus upon I. Therefore I plus is nothing but the v plus, that is velocity, plus z plus n plus e upon d. Okay, therefore I total current is nothing but the z plus n plus e v plus v minus upon t. Okay, therefore this is equal to v plus then z plus n plus e upon d into, this will be revert d upon z plus n plus e v plus v minus. Okay, therefore small same term d cancel, z cancel, n plus cancel, e cancel, e cancel. Okay, new equation after cancellation is obtained will be is equal to t plus, that is a transport number, v plus upon v plus v minus. Okay, this is the new equation you obtain. Similarly, for the t minus, that is transfer of number of anions, is equal to v minus upon v plus v minus. Okay, this term not change. Okay, this only plus and minus will be changed. Okay, then we'll find out the divide this equation with this equation. T plus upon t minus is equal to v plus upon v plus v minus into, okay, therefore this will revert, that will be is equal to v plus v minus upon v minus. Therefore same term is cancelled, therefore t plus upon t minus is equal to v plus upon v minus. Okay, therefore by observing this equation, t plus, the transport number or transference number is, or transference is directly proportional to the its absolute velocity or the migration velocity. T minus is depends upon its absolute velocity. Okay, that is new equation. And remember that t plus summation of the transport number cations and anions is always 1. Okay, this is the relation of the transport number with the its absolute velocity. That is all about the transport number and the transference. Okay, thank you very much.